Hello students, let us solve question 3 of this paper. So we have a triangular piece of land ABC which has an area of 60 meters square. And let us start with a simple diagram. So it is given AB is 15 meter. So this I label as small letter A, this is small letter C, and this is small letter B. AB is 15 meter, AC is 10 meter, and angle BAC, this angle is given as theta. Show that sine theta is equal to 4 by 5. We know that the area of a triangle can be written as half AB sine C, or it can be written as half BC sine A, or it can be written as half AC sine B. You can use the appropriate formula that can be applicable over here. So here we know sine A, or this angle A, we need to involve that angle A in the formula. So we need to use this formula for the area. Okay, so area is a non-quantity over here. Area is given as 60 meters square, so we can write 60 is equal to half multiplied by B multiplied by C multiplied by sine A, which is nothing but sine theta. So just rearrange the terms. You can cancel off the 10 over here and just bring the 2 to the other side and divide it by 15. You get sine theta. In the simplified form, this is going to be equal to 4 by 5. So this 1 mark is for that complete proof. Okay, now coming on to the next section, given that theta is the largest angle in the triangle, we need to find the length of the side BC in meters correct to 3 significant figures. Okay, so we already calculated theta, which is sine in the form of sine theta, which was equal to 4 by 5. Now, when we take the sine inverse of this one, that is sine inverse of 4 by 5, we are going to get the value of theta. If you do it on a calculator, you are going to get an angle of 53.1 degree, but it is given that theta is the largest angle in the triangle. So if it is 53.1, we still have 180 minus 53.1 degree left in that particular triangle. This is actually how much? 126.9 degree left in that particular triangle, right? So from this 126.9, we can actually make uh, another angle of the triangle which is greater than 53.1. So this won't be the largest angle in this, can't be the largest angle in the triangle. Okay, so one particular combination I'll tell you, if I split this into 90 and 36.9, the third angle is 53.1. This would be the largest angle in the triangle. Okay, so theta won't become the largest angle in the triangle. So here we make use of the principle of ambiguous sign rule. Okay, so which states that if one angle is theta, which is 53.1, the same sign value we can get for another angle of theta, which is equal to 180 minus 53.1, which is equal to 126.9 degree. Okay, so from now onwards, we need to take sine theta is equal to 4 by 5, but the particular value theta we are going to use over here is 126.9 degree. This is the angle that we are going to use. Okay, so I am going to just redraw the figure a little bit like this. So this is the angle over here, that is now 126.9 degree. Okay, then this was 15 meter, this was 10 meter, this is A, this is C, and this is B. Now the question was to find the length of the side BC correct to 3 significant figures. So whenever you have in a triangle 2 sides and the angle in between, you can apply only cosine rule. So here we need to apply the cosine rule to find BC, or in other words the length A, denoted by the small letter A. So we apply the cosine rule, which is A square is equal to B square plus C square minus 2BC cosine of A. So we know the value of B, which is 10, C, which is 15, and the angle is 126.9 degree. So you can solve it on your calculator and find the value for A. So you will be getting A square as 505, and the value of A is equal to 22.5 centimeter. So this is nothing but BC. So BC is equal to 22.5 centimeter. Okay. We'll discuss the mark division also along with. So the first mark goes for finding out the ambiguous sign rule part. So if you find out the ambiguous sign rule part according to that this angle, you'll be getting the first independent mark. Uh, Alternatively, if you find out the angle of cos, the total value of the cos theta also, that also is fine. So in that case, the cos theta would be equal to minus 3 by 5. So if you get this value also, that is also fine. But this is more simple. So if you use the ambiguous sign rule to find out 126.9 or approximately 127, you'll get the first independent mark. Okay. The second mark goes for finding out uh, the calculating the cosine rule using the cosine rule. If you get the correct method, then you'll get the method mark for this one, and the last mark goes for the accuracy mark. Okay. Now the last part is to find the size of the smallest angle of the triangle. So you already have one angle over here, and now you found out this side also, which is 22.5 centimeter. So you can use sine rule now because you have all the three sides of the triangle and one angle. So you can use sine rule now to find out the second angle. So I'm using, I mean, you can find out any angle. You can find out either B or C, whichever you want, you can find it out. Okay. So maybe I'll start with B. So sine B divided by B is equal to, then this is the known thing that I have, sine A divided by A. So sine B, I don't know, this is an unknown quantity, but the length B I know, which is 10. Sine A is already given in your question, or you already calculated it, which was equal to 4 by 5, and the value of A is what you calculated it now as 22.5. So now when you solve this, you'll be getting the value of sine B, and from this you can get the value of B. So the B value you will get approximately equal to 20.9 degree. Okay, so you have A is equal to 126.9, B is equal to 20.9, and C will be equal to, if you take the total angle as 180 degree, you'll be getting C is equal to 32.2. So this means that the value of B is the smallest angle, which is equal to 20.9. You have to write it to one decimal place. So 20.9 is the correct answer. Okay. So here the marking scheme is quite straightforward. The method carries one mark. The method of finding out using the sign rule, this carries one mark, and the final answer carries the accuracy mark. Okay. So I hope you are able to follow the question. Thank you.